जगडे मॅडमला पाठवून द्या आणि तृप्ती चव्हाण मॅडमला पाठवून द्या.
Good morning. Participants are joined. Please wait for 2 or 3 minutes.
Vinod sir, can we start with the initial formalities? In the meantime, the other people will join.
Yes, ma'am. Yes.
Am I audible?
Yes, ma'am.
Good morning, everyone. I am Aishwarya Prashant Reddy, working as a lecturer in Mechanical Department at RIT College, Lohegaon, Pune. A very warm welcome to all distinguished speakers, faculty members, and participants. It gives me immense pleasure to welcome you all the 3-day faculty development program on artificial intelligence and machine learning, organized to enrich our knowledge and enhance our understanding of the emerging trends in AI and ML technologies. Brief introduction about the FDP. This 3-day FDP has been designed to cover essential aspects of AI and ML and significance of data science to exploratory data analysis and practical machine learning applications. Day 1, Introduction to Artificial Intelligence and Machine Learning by Dr. Rachna Sabre ma'am. Importance of Data Science and Resources by Dr. Deepika Athalkar ma'am. Day 2, Exploratory Data Analytics, Data Collection, Data Cleaning, and Data Pre-processing by Professor Rahul Kurate sir. Day 3, Machine Learning Applications by Professor Rahul Navle sir. To commence today's program, I would like to invite Professor Vinod Jadhav sir, HOD Computer Department, to give a brief introduction about the FTP, its objectives, structure, and expected outcomes.
Good morning, uh, all the participants. Today we are organizing the program on the AIML, the Faculty Development Program on AIML aims to provide educators and researchers with the understanding of the rapidly evolving domains of AIML. In today, in digital era, these technologies are transforming every from health and finance to manufacturing and education by enabling intelligent system capable of learning, reasoning, and decision making. The program also focuses on bridging the gap between industry practices and academics learning through hands-on sessions and expert talk of Dr. Saple ma'am and Nowle sir. These are the important the expert talks and the Rachna ma'am, all this. These are the interactive session which all the participants are for that these interactive sessions are welcoming from the RIT Polytechnic Lohegaon, Pune. Thank you. Thank you very much.
Thank you, sir, for enlightening us with your valuable insights and for setting the tone for this FTP. Next, I would like to invite our respected principal, sir, to share his.
Good morning, sir.
Yeah, good morning.
Next, I would like to invite our respected principal, sir, to share his encouraging words with us.
Good morning to everyone present here. It gives immense pleasure to me to be part of this 3 days faculty development program on artificial intelligence and machine learning for beginners. This FDP is happening under the Margadarshan scheme of K.E.Society, who are mentors with us, G.H. Raisoni College of Engineering in Pune. We are the beneficiary, K.E.Society Education Society's Rajarambapu Institute of Technology, Polytechnic, Lohegaon, Pune. We found this Margadarshan scheme is very useful for upgradation of our current system. As I see the objectives of this FDP at fundamental concepts of artificial intelligence and machine learning, introduction of that, and familiarization of AI and ML tools also, programming framework, developing skills in the data pre-processing, model training, and the evaluation to understand real-world applications of AI/ML in engineering and research, and to motivate faculty to integrate AI/ML concepts into the teaching projects. And I'll add the documentation also, the third part also, because we are, as a teacher, we have to go through a lot of formats, preparation of teaching plans, examination, short quizzes. There are many more teaching related or the examination related work we have to perform. In that case, the formatting work has to be minimized by using the AI tools also. I think that this FDP will definitely highlight all these pinpoints or the pinpoints of our faculties, which will make us very much comfortable by using the tools. As we see in Word and all Excel also, we find the assistant. There is an assistant is coming in a place when we see that. So definitely all the speakers which we throw light on this, Dr. Rachna Sabre Madam, Dr. Deepika Ajalkar Madam, Mr. Rahul Borate Sir, and Mr. Rahul Navle Sir, definitely help us. And I thank the coordinator of this Margadarshan Kim, Dr. Anil Sahu Sir, and director of G.H. Raisani College, Pune Sir, giving this insight to us and helping us to carry out this FDP and making all the participants beneficiary by understanding the concepts and throwing the light on these new technologies and the daily use of AI/ML in teaching, learning, and documentations also, and developing other activities which are happening here. So this online FDP will cover for next 3 days, 7, 8, and 10. And definitely, I think that all the participants will witness this FDP as one of the knowledge enriching sessions in their total journey of this skilling and upgradation of the knowledge for their self-development, and that will definitely going to help to the institute also for making the use of, and for finally the students which are going to understand through these teachers how this AML is going to change whole spectrum of education system when we see it. So I request all the organizers and the speakers and wish very grand success to this FDP for next 3 days. Thank you.
Thank you, sir, for your inspiring words. Now I proceed by highlighting today's agenda and providing a brief introduction of our distinguished guest speakers, Dr. Rachna Sabre ma'am. Dr. Rachna Sabre ma'am is an accomplished academic and researcher with a PhD in computer science from Bennett University 2024 and over 17 years of experience in teaching, research, and leadership. She currently serves as assistant professor and head of the Department of Artificial Intelligence and Machine Learning at G.H. Raisoni College of Engineering and Management, Pune. Her research focuses on AI, machine learning, deep learning, and predictive analytics, with applications in stock market forecasting, medical imaging, and generative AI. She has published extensively in reputed journals and conferences, contributed a book chapter with IGI Global, and holds multiple patent and copyrights. Dr. Sabreman has received awards including the Jesht Acharya Award 2024 and Best HOD Award 2022. She actively contributes as a reviewer, session chair, and mentor in national and international forums, securing AICTE and SPPU funding for FDPs and conferences. A member of S4DS and CSI, she also serves as BOS chairperson, and academic council member, driving innovation and collaboration in AI education and research. Now it's time to begin our faculty development program on artificial intelligence and machine learning. We are truly honored to have with our distinguished speaker, Dr. Rachna Sabre ma'am, who will be delivering the first session on Introduction to Artificial Intelligence and Machine Learning. Ma'am, we request you kindly commence today's FTP session and share your valuable insights with us.
Thank you, ma'am. Am I audible and my screen is visible?
Yes, ma'am.
Yeah. So good morning, everyone, and a very warm welcome to this faculty development program on basics of AI and ML for beginners, organized by Rajarambapu Institute of Technology, Pune, in association with G.H. Raisoni College of Engineering and Management under AICT Margadarshan Scheme. I am Dr. Rachna Sable, Assistant Professor and Head, and it is my pleasure to be your speaker for today's session. In this presentation, as a first day session, the name includes Introduction to AI and ML. We will explore how artificial intelligence has evolved over the years, understand its subfield ML, deep learning, generative AI, and examine the algorithms and techniques that form their foundation. By the end of this session, you will be having a clear picture of how each stage of AI development has overcome the limitations of the previous one and paved the way for today's intelligent and creative system. Even as the principal sir said that the use of AI for education, documentation, various tools are available like Notebook LLM is there, Canvas is there, Gamma is there, Notion is there. So surely in the upcoming hands-on session, we will surely try to tell the faculties how to use those tools and how to make use of it to enrich the documentation research in the education. So we will be starting with our session by this. So is it visible now? Shall we start?
Yes, ma'am.
Yeah. So now we all are live in the digital age. We have data all around. We need to make decision in every day, in every life. Since morning we get up, we have to think of, we have to take the decisions. Likewise, if we want to go for a restaurant, if we want to go for a movie, nowadays, what are we doing? We are just checking the reviews. Oh, which restaurant is good? Which movie is good? What are the rating given to that particular movie, to that particular restaurants? Likewise, our decision is based on the data which is all around. So AI is playing a major role, we can see, in our daily lives. So in this presentation, the first image shows you the broader domain in AI, which is subfield as ML, then neural network, then deep learning, and then generative AI. AI is in every domains, like Sir said, it is into education, it is into finance, it is into healthcare, and so on. So the main aim, what was the thought process in 1950s? AI is not that came into picture currently. It was during 1950s. The AI came into existence. But why it was not in boom at that time? Because data, because of the data, processing of data, collection of data, storage of data, that was not there. So since now all those facilities come up, AI came into boom. So what was the role of AI? What came into picture? We thought of making the machine or making a system that can imitate human intelligence, that can think like human, that can behave like human, that can make decision making like human. So that was the thought process behind the AI, making the system likewise. Then came the machine learning, a subset of AI. They thought that why not to make a machine that will be able to learn automatically on their own, like we humans today learn on their own. So the advent of machine learning came up. Then why deep learning was required? Here we want to mimic human brain now, how we think. Our thought process has to be embedded into the machine learning model. That was the process of forming the deep learning. That is making machine mimic how the human processes the information. So that was the thought process. So these are the basic major categories. So, as I said, that AI making machines think and act independently, autonomously, doing reasoning, problem solving, decision making like humans. So, what were the key features that was thought? So, in the earlier era, as I told you, that AI focused on rule-based system that used symbolic reasoning and logic. So what the system focused on? The system focused on the predefined rules which were written by the experts, allowing computers to perform reasoning and decision making tasks. अगर ऐसा होता है तो ऐसा करो, अगर वैसा होता है तो वैसा करो. All the rules were defined in the predefined manner. But now we live in a real world. But now as real world problems become increasingly complex and diverse, the rule base struggle to cope up with the uncertainty. Now every minute there is a dynamism, there is a change. So writing the rule for every particular decision making was a great challenge. So that became the limitation of the AI, that it could not learn automatically from the data. We need to do the explicit programming of that. We have to write the rule, we have to frame the boundary. That became very important problem. So therefore it failed when rules became too complex. Uncertainty was not handled by AI. It could not adapt with new changes, new scenarios. So therefore the need of machine learning came into picture, where we want the systems to learn from data. But now, as we said, the AI is a major domain, so it has applications in various areas like chatbot, autonomous vehicle, healthcare, diagnosis, smart assistants. All these are the major areas which are named as the AI applications. So hence, here came the need of machine learning. So now, as we have discussed in our previous two slides, like machine learning will now help the system to learn from the data and make the decision based on the past data. And every time I did not need to do the programming for the same, which was the previous tedious task for the AI systems. So what are the key features of machine learning? It learns automatically. It improves performance over time, keeps on learning, keeps on improving. Various algorithms like machine learning algorithms that we are going to see now. What are the various machine learning algorithms like regression, SVM, clustering, all were used to improve, to analyze the input data and predict the outcome on what they have learned from their past data. So what was the strength of machine learning then? The strength of the machine learning is ability to generalize. Ability to generalize means what? I have written generalizes pattern from seen data to unseen data. Means the aim was to make a general system which will learn from the past data and apply to predict on the new data, whatever it has learned. For examination also we go, we study, and then whatever we have learned, we try to give the generalized answer. हम लोग कीवर्ड यूज करते हैं ना, पहले पढ़ के जाते हैं सारा पास्ट का जो भी हमें सिलेबस दिया होता है, एंड व्हाटएवर क्वेश्चंस दैट कम इनटू पिक्चर, देन ऑन द अनसीन डेटा वी ट्राई टू अप्लाई. So we try to make the general model in the machine learning. But again, then what were the limitations of machine learning जब इतना सब कुछ कर रहा है system? So it needed manual feature extraction. Now if I say a human being, so what are the features of human beings? Maybe the face, maybe the nose, maybe the eyes, hands. These are the features. The color, the length of the hair, all are these are the features, correct? Which will help me identify based on the feature whether it is a human, whether it is an animal. So these feature extraction in machine learning were done by the human beings, and then the extracted features were provided to the machine to do the prediction. That was the limitation of machine learning. So the accuracy was limited and the models were not that scalable. So here came the need to automatically learn from features. जैसे हमने देखा कि AI में हमें मशीन मिली जो रूल बेस्ड थी, जो रिजिड थी, लर्न नहीं कर सक रही थी अपने आप से. Then we came to machine learning, where we made the machine to learn automatically from the data. But again, what was the problem? Learn तो कर रही थी, but feature extraction के लिए human की help चाहिए थी. So here came the need of deep learning. which will automatically learn from data and it will remove the human intervention with the system. So that was the advent of machine learning. So some of the application of machine learning area is email spam detection, credit scoring, and crop recommendation. So in broader, these are some of the application. So now we come to deep learning. So deep learning, see, the image here shows the clarity, whatever of what I have said, that input, and then the human is extracting the feature, and then it is providing to the machine learning model, and then machine learning model is classifying whether the input is car or not car. Whereas in deep learning, you can see the input is directly given to the model, and model is doing the feature extraction and classification. Sir, I hope my pace is okay. Sir, am I audible?
Yes, madam.
Yeah, okay. My pace is okay, Rahul sir?
Yes, madam.
Okay.
Your PPT is not showing.
Yeah. I just minimized it so that I could ask you whether the pace is okay or I should go slow.
It's fine. It's fine, madam.
Yeah. So I was at deep learning. I was talking about the image, correct? There we can see the difference between the deep learning and machine learning, where in machine learning, the feature extraction was done manually, and in deep learning, the feature extraction and classification or the prediction task was automatically done with the system. So the key features of deep learning were the automatic feature learning. The human intervention was reduced. Large amount of data set is required for training a deep learning model, and even the computational power required is more. So therefore, the fields where it is being used is computer vision, speech recognition, natural language processing, and it forms the basis of technologies. Nowadays, we have facial recognition, autonomous vehicle, and then intelligent virtual assistants and medical imaging. So these are the various applications where deep learning finds its way out. But again, what were the limitations with this deep learning? It required huge amount of data, extensive hardware. Even it is a black box. Now, why we are calling it a black box? Because whatever the feature extraction or the model training is being going on, the people are not aware of it. Therefore, it is a black box. I am not aware of what is being done internally. So even the high energy, cost and training time is required to train the model for deep learning. So therefore, again, with this large amount of data, computational power, became a new thing which is called as generative AI or Gen AI nowadays. So it normally represent a transformative leap, a dynamic change in the AI technology. Now, what we are doing with generative AI, we are generating new content like text, images. The name itself tell you generative AI. We are generating something that is text, image, music, code or video that mimics ह्यूमन क्रिएटिविटी. जैसे हम कुछ क्रिएट कर सकते थे, वैसे हम ऑटोमेटिकली एआई के थ्रू जनरेट करवा रहे हैं टेक्स्ट, इमेजेस, वीडियो. सो व्हाट आर द की फीचर्स ऑफ जेन एआई? The traditional model like AI, ML, DL, they were only classifying or predicting. But Gen AI can entirely create new data by learning the patterns of the existing data. So how it can do? It can do with the power of LLMs, large language models and transformers, which understand the context, intent and style and learn from high multimodal data by speech or by written. Either you can speak and generate, I can you then write and generate. Therefore, it is said that it learns from high multimodal data set. So it can find its application in chat GPT, Del E. टेक्स्ट जनरेशन अगर हमें करना है तो हम चैट जीपीटी आजकल सारे लोग यूज कर रहे हैं, टेक्स्ट जनरेट कर रहे हैं. इमेज जनरेशन, डेली और मिड जर्नी कैन बी यूज. If you want to generate the code, GitHub Copilot for writing the software code is used nowadays. For video generation, Runway ML can generate short videos. which can use for educational purpose also. So these are the various applications where Gen AI can find its way out. Again, but what are again the limitations? The limitations are that it can sometimes produce incorrect or biased information, because वो भी हमारे दिए हुए data से ही trained है. So it may happen that it can sometimes produce incorrect or biased information. Again, there can come ethical and privacy concern. आपने आपका कुछ sensitive data अगर दे दिया है तो it will be available to everyone because it is open source, that can be misused. So ethical and privacy concerns again come into picture, and computational cost again will be high, and of course generative AI can then ethical and privacy concerns. So there comes a need of human oversights for safe and factual data. Even though machines or AI systems can do a lot on their own, but still human monitor, guidance and validation of the work is always required. That we have to keep into mind. So this was about the generative AI. Now we switch to the comparative analysis of what we have gone through 3 or 4 PPTs that we have done up till now. What we have seen: AI, again rule based, no learning, rigid, ML is required. ML learns through data, but manual feature extraction was required. So we moved to DL, that is deep learning. In deep learning, neural network was used, high cost was involved, creativity was not there. Whatever data we were providing, it was learning through it and it was giving us the prediction or classification, whatever was required. So again, generative AI came into picture, and then Gen AI came. Then again, what were the major concerns? Bias, it was bias, ethical concern and cost. So now ongoing research are going on, responsible AI, explainable AI, these are coming into pictures. So now with the general introduction, we will start with the types of machine learning. So after having understood the evolution of AI, now let us examine the 3 types of machine learning, which is supervised, unsupervised and reinforcement learning. We'll go through the first type of machine learning, that is supervised. Why it is called supervised? Because the learning of the model is done under the supervision. The model is trained on label data, and what the algorithm is doing? The algorithm learns to map the input data to the correct output. Here we have y is equal to f of x, means a function is required that will map my input data to the correct output data. That is what is called as supervised learning. हमें बचपन में सिखाया जाता है ना, मम्मी बैठ के सिखाती है हमें कि दिस इज द इमेज ऑफ एन एप्पल, दिस इज एन इमेज ऑफ एन ऑरेंज, एंड देन शी टेक्स आवर टेस्ट कि भैया बेटा ये बताओ व्हाट इज द इमेज दिस इज फॉर, देन वी आंसर एप्पल. So that is the supervised learning. The very important factor of the supervised learning is the labeled data. Data labeled होना चाहिए. Then second came the unsupervised learning. In unsupervised learning, data has no label. You can see the image of cat and dogs are provided, but label is not there. So here the model must find the hidden patterns, similarities on which it will do the grouping of the data set. You can see from this image, label नहीं दिया गया है, similarity find करेगा, maybe similarity, it has 2 ears, what is the color of the feather, how many legs are there, tails are there, what is the nose and all. Then based on the similarities, it will try to find, based on the features, it will try to identify and make the clusters. Now, on what basis it will find the similarities and make the cluster? There are various distance measuring formulas and all, Manhattan, Euclidean distance and all, which are used for clustering the data for the output. Then the third type of machine learning is the reinforcement learning. Reinforcement learning is what? It is based on the feedback. Okay? In the what we can say, in the organization also, if we perform some task, then if the task is okay, we get the feedback कि हाँ आपने बहुत अच्छा काम किया, and we get the reward. And if the work is not good, we get the punishment. And based on the punishment, we try to improve ourselves कि अगले बार मुझे ये गलती नहीं करनी है. That is what is called as reinforcement learning. Model will learn through interaction with the environment, and then it will get the feedback on the basis of reward or punishment, जो वो नोट करके रखता है कि अगर मैंने ये एक्शन लिया था तो मुझे इसके लिए हाँ अवार्ड मिला था, ये एक्शन लिया था इसके लिए मुझे punishment मिली थी, so I should not repeat this action in the future. That is what the model is learning. It is exploring, and where it has to stop, it will decide the action based on that. That is what is called as the reinforcement learning. So after knowing the basic machine learning types, that is supervised, unsupervised, and reinforcement, in the further slides we will get to know what are the supervised algorithm, one example of unsupervised, and then the reinforcement. I hope up till now I am clear and I should proceed.
Yes, ma'am.
So this is the basic machine learning architecture, where the first step is data collection, processing of the data, then the feature extraction, then the model training, and then evaluation of the model, whether the model is giving the correct output or not. So these are the four basic blocks of the architecture of the machine learning. Now in supervised machine learning, as we have already discussed, the training is done on labeled data. Corresponding to each data point in the data set, there is an output given. Then what we have to do, y is equal to f of x, where y is the dependent variable and x is the independent variable, and we have to find the relationship between the independent and dependent variable. And this relationship between the variable x and y will help me make the predictions on the unseen data. So now supervised machine learning, there are two types. One is called as regression, another is called as classification. So these are the two types of supervised machine learning. So regression and classification. Now regression will deal with what? Regression will deal with the continuous numeric values, and classification will deal with what? Discrete or categorical value, like yes, no, male, female, spam, non-spam. These are some of the example of classification. And regression, stock price prediction, temperature prediction, weather forecasting. So these are all the examples of regression. So we will be moving to the first type of supervised machine learning, that is regression. So regression is a statistical method where we need to find the relationship between dependent and one or more independent variable. Now again and again we have to keep into the mind that dependent variable is the output variable y, whereas independent variable is the x, that we are providing the input, and based on the input the dependent variable output is there, and every time we have to map it. So in regression, how are we mapping? How are we predicting? We are predicting by fitting a linear equation and finding the best line which will give me the prediction. So regression also have two types. When only one independent feature and one dependent feature is there, we called it a simple linear regression or univariate linear regression. एक x होगा, एक y होगा, x को y के साथ मैप करेंगे, that is a univariate linear regression. And when we have more than one feature, more than one independent feature, we called it a multiple linear regression. See, this is the picture of simple linear regression, जहां आपको एक independent variable x दिख रहा है, एक dependent variable y दिख रहा है, and we can see a straight line which is helping us doing the prediction. Now, how this line will be help me in doing the prediction? It is using the equation y is equal to mx plus b. ये हमने काफी टाइम मैथमेटिक्स में भी पढ़ा है, straight line का equation y is equal to mx plus b, where m represents the slope of the line and b represents the intercept. X is the input variable and y is the dependent variable. So ये best हम so there are n number of lines on this plane. Now what is our goal? Our goal is to find the best line. The goal of linear regression is to find a straight line that will minimize the error. Now, for example, अगर आप stock market से related, if you have an information, अगर Apple stock का price आज 100 rupees है और हम प्रेडिक्ट कर रहे हैं सपोज कि स्टॉक एप्पल का प्राइस कल 105 होगा, बट एप्पल का जो हमने 105 बोला है, लेकिन एक्चुअली जो हुआ प्रेडिक्ट वो 103 हुआ, then 105 minus 103, error of 2 is there. So for every data sample we will calculate the error, and accordingly the line is being adjusted so that it will provide me the position that will minimize my prediction error. So that is the goal of best fit line. See, x की वैल्यू 1 है, y की वैल्यू 3 है, predicted value. So actual minus predicted value is shown here in the squared error. हम एरर निकालेंगे ना, एक्चुअल और प्रेडिक्टेड की वैल्यू क्या है. So 3 minus 0.007 will give me the error. Accordingly, for all the data points, you will make the table, you will find out the error, and based on them, you will do the plotting. This curve is called as gradient descent curve, which will help me find the optimal parameters of the line. मेरे लाइन के लिए कौन सा बेस्ट स्लोप का पोजीशन था, कौन सा बेस्ट इंटरसेप्ट का पोजीशन था, जिसके बेसिस पे मैंने एडजस्टमेंट करके मेरे प्रेडिक्शंस निकाले हैं. सो दिस इज द gradient descent curve. Now you can see this black ball which is coming down. This is the local, this is the minimum cost where I should reach. So how I should, whether I should increment my learning rate, whether I should decrement my learning rate to reach this global minima, that is what is the aim of gradient descent. और जब आप ये gradient descent minimum cost पे आ जाएंगे, then you get the optimum parameter, and that is your best line coefficients or the parameters we have read. So for example, predicting a person's salary based on the number of years, एक x है एक y है, number of years के basis पे आप predict कर रहे हैं what is the salary of that particular person. So this is one of the example of the simple linear regression. I hope I am clear.
Yes, ma'am.
Yeah. So what is the advantage of simple linear regression? We have to do nothing. हमने क्या किया? We have collected the numeric data, we have interpreted the data, we have analyzed the data, and based on that, we have find out our best fit line, we have optimized the parameter, and then we have made the prediction. जिस parameters पे हमें सबसे minimum error मिलता है, those are our optimal parameters. All these things you will get to do in the hands-on also in the upcoming sessions. You have to just remember the concept, whatever we are going through, and then you will be doing the hands-on tomorrow and day after maybe on that. So advantages of simple linear regression is it is easy to understand and interpret, predicts future outcome as we have seen, computationally efficient है, simple है algorithm, and it is the most widely used techniques in statistics and machine learning. But again limitations क्या है इसके? लीनियर रिलेशनशिप होनी चाहिए, मतलब x अगर चेंज हो रहा है तो कॉन्स्टेंटली y भी कुछ रेट में चेंज हो रहा है. सो दैट लीनियर रिलेशनशिप इट अज्यूम, दैट इज वन ऑफ the drawback or limitation of this simple linear regression we can say, and it is sensitive to outliers. Outliers क्या होता है? Suppose I have a data set where I have a value of 10, 20, 30, 40, and instantly I get a value of 10,000 in that particular cluster. So that become a outlier which will affect in my result. So that outliers के लिए simple linear regression is sensitive. So that is the limitation. So next comes the another type of regression which is multiple linear regression. So multiple linear regression, it extends the concept of simple linear regression by considering two or more independent variable. We have seen earlier also in simple linear regression we have only one x and one y, and we map the relationship. In multiple linear regression we have multiple x and we predict y. Now for example, जैसे यहाँ real estate pricing, financial forecasting, agricultural yield prediction I have given the example. So अगर हाउस प्राइस प्रेडिक्शन के लिए हमें देना है पैरामीटर्स, सो व्हाट आर द इंडिपेंडेंट पैरामीटर्स? अगर आपको कुछ घर खरीदने जाना है, सो यू विल टेल द वेंडर कि बाबा दिस इज द नंबर ऑफ बेडरूम्स दैट आई रिक्वायर्ड, दिस इज द एरिया दैट आई रिक्वायर्ड, दिस इज द स्क्वायर फीट व्हिच आर रिक्वायर्ड फॉर द न्यू हाउस दैट आई एम गोइंग टू take, this is the location, what type of neighborhood is required. So these are the n number of independent features which you are providing to that broker, and according to this the broker will tell you the predicted price ki bhaiya with all these features aapko ye rate mein ghar mil jayega. So there are n number of multiple features. Now all the features are not every time important, correct? सो सम ऑफ द बेस्ट फीचर्स जो आपके लिए इंपॉर्टेंट है उन्हें हम ज्यादा वेट्स देते हैं, बाकियों का वेट्स कम होता है, जो इक्वेशन आपको दिख रहा है, एंड अकॉर्डिंगली द प्रेडिक्शन इज डन फॉर द मल्टीपल लीनियर रिग्रेशन. This model provides deeper insights by quantifying how much factor contribute to the prediction, which important factors are there. So the important point that we have to remember in multiple linear regression is the multicollinearity. Multicollinearity means आपके independent variables कितने correlated हैं. अगर घर खरीदने जा रहे हैं और आप मूवी की बात कर रहे हैं तो that feature is not correlated with the house price prediction. Correct? So multicollinearity is one of the important factor that we have to keep in mind while dealing with the multiple linear regression. Now we have studied the first type of supervised algorithm, that is the regression. Under regression we have done the simple linear regression, multiple linear regression, and now we will see after generating the model, evaluation of the model, whether it is working correctly or not. We have to need some evaluation metrics. So these are some of the evaluation metrics used for regressions. Many a time in the interview also the questions are asked कि आप सुपरवाइज में रिग्रेशन मॉडल बना रहे हैं, उससे डील कर रहे हैं, तो क्या इवैल्यूएशन मेट्रिक्स आप यूज करते हैं मॉडल को इवैल्यूएट करने के लिए. So immediately we are not able to get the point. So some of the evaluation metrics that we used for linear regression is mean square error, which calculates the average square distance. See, average is taken 1 by n, and it is the average square distance between the predicted and actual value, yi and yi hat. That is the difference between the actual and predicted. So this is one of the metrics that is used for evaluating the regression model. Then root mean square error, जो आपने ऊपर निकाला है आप उसका रूट लेते हो. Then mean absolute error, where you measure the average magnitude of error regardless of the direction. यहाँ पे हमने mod में लिया है. So these are the three means some of the evaluation metrics that we used for the regression model. Now the most important concepts that come into picture कि what is loss and cost function. When we talk about regression, we know that it is dealing with the numeric values. तो अगर मेरा मॉडल पूरा डेटा सेट पे वर्क करता है तो भैया इसका कितना लॉस या कितना कॉस्ट इसमें आया इसका पूरा इवैल्यूएशन में, दैट वी नीड टू कैलकुलेट. सो व्हाट इज द डिफरेंस बिटवीन लॉस एंड कॉस्ट फंक्शन? If I take one single the training example, like I told you कि if in stock market Apple's predicted price is 105 and actual price that I got is 103, so what is the error? 105 minus 103, 2 is the error. So that is the loss function. सिंगल ट्रेनिंग एग्जाम्पल में आपको जो एरर मिलता है, और ऐसे आपके पास 1000 डेटा सेट में पॉइंट्स हैं तो 1000 डेटा सेट का एरर आपको मिलेगा. जब आप उन सब का एडिशन करते हैं, एवरेज निकालते हैं, तो ये सब लॉस फंक्शन मिला के आपको जो एवरेज मिलता है, दैट बिकम्स योर कॉस्ट फंक्शन, व्हिच इज डिनोटेड बाय J. This is the formula for calculating the cost of the problems which are coming, the important concepts like overfitting, underfitting. You might have heard all these points, what is overfitting and what is underfitting, yeah, what is bias variance trade-off. So underfitting and overfitting, while training a model, just now we have discussed कि हमारा जो ऑब्जेक्टिव है वो क्या है, मिनिमाइज करना. क्या मिनिमाइज करना? we have to minimize the cost function. What is cost function? Cost function is giving me the average of the error, minimum error. So what is this bias and variance? Now we have the three types of data. हमारा अगर डेटा सेट है 10,000 सैंपल्स का, तो that data set is always divided into three type, or many of the time it is divided into two type. One is called as training data, one is called as testing data. And another part which comes into picture is called as validation data. So training data is what on which the model is trained. हमें अगर कोई काम दिया जाता है ऑर्गेनाइजेशन में, हम वो काम परफॉर्म कर करके वी गेट ट्रेन टू इट. नाउ व्हाट इज द जॉब ऑफ वैलिडेशन? वैलिडेशन डेटा सेट क्या करेगा? इट विल ऑप्टिमाइज माय वर्क, इट विल चेक, इट विल सर्टिफाइड कि वेदर एज पर द स्टैंडर्ड ऑफ माय ऑर्गेनाइजेशन आई एम परफॉर्मिंग दैट वर्क और नॉट. And testing is what? Actual evaluation of your work, whether it has been done correctly or not. So why these two terms are required, bias and variance? So bias will give me the error between the training data and testing data. मतलब जो actual और predicted का error रहेगा वो हमारा bias रहेगा. The error of training and variance will provide me the testing error. So मुझे ट्रेनिंग का भी एरर कम चाहिए, मुझे टेस्टिंग का भी एरर कम चाहिए. मीन्स आई विल नीड अ मॉडल विच विल गिव मी लो बायस एंड लो वेरिएंस. दैट इज ट्रेनिंग एरर भी कम देना चाहिए, टेस्टिंग में भी एरर कम देना चाहिए. दैट मॉडल विल बी अ गुड मॉडल, दैट विल बी अ जनरल मॉडल. करेक्ट? अगर हम 10 क्वेश्चन देते हैं एग्जाम के लिए, हम 10 क्वेश्चंस पढ़ के जा रहे हैं और एग्जाम में कोई 11th नया क्वेश्चन आता है, सो वी आर नॉट एबल टू आंसर दैट पर्टिकुलर बिकॉज वी हैवंट बीन ट्रेन्ड ऑन दैट. सो माय मॉडल शुड नॉट वर्क ऑन दैट कि मुझे लिमिटेड ही ट्रेनिंग दी है और वो ट्रेनिंग के बियॉन्ड आई कांट गो. सो माय मॉडल शुड बी अ जनरल मॉडल. सो नाउ व्हाट इज दिस ओवरफिटिंग, व्हाट इज दिस अंडरफिटिंग? सो सी द फर्स्ट फिगर शोज यू अ स्विगली लाइन, जहां आपको सारे पॉइंट्स वो लाइन पे दिख रहे हैं. मतलब क्या है? मॉडल मेरा बहुत अच्छे से ट्रेन हुआ है ऑन ऑल द सैंपल्स. सो ओवरफिटिंग हैपेंस व्हेन वी ट्रेन अ मशीन लर्निंग मॉडल टू मच on the training data. As a result, the model learns the training data too well but can't generate good predictions for unseen data. Training I have done very nicely, but when now new example is given to it, I am not able to solve. That is called as overfitting. Now in underfitting, you can see the points you can see are spreaded here, and this is the prediction line. So you can say see the error between the actual and the predicted. Means the model here is not properly trained. So that is called as underfitting. जहां मेरा लॉस जो होता है ट्रेनिंग टेस्टिंग में बहुत ज्यादा होगा, ट्रेनिंग का ही एरर मेरा बहुत ज्यादा होगा यहाँ पे. So that is called as underfitting. And the middle figure you can see, that is called as fitting. This type of model is required which will give me less error. देखिए आप बेस्ट फिट लाइन जो आपको दिख रही है ये कर्व में, और जो ब्लू डॉट्स हैं वो एकदम आपके लाइन के आसपास ही है. मतलब वो ट्रेनिंग और टेस्टिंग एरर, आपको जो ट्रेनिंग या टेस्टिंग एरर मिलेगा वो मिनिमम मिलेगा. सो द मॉडल शुड नॉट बी ओवरफिट, द मॉडल शुड नॉट बी अंडरफिट, बट इट शुड बी अ फिटिंग मॉडल, गुड फिट मॉडल. सो वट एवर आई हैव टोल्ड यू, आई हैव रिटन हियर. जो हमारा ओवरफिटिंग मॉडल होगा दैट विल बी टू कॉम्प्लेक्स बिकॉज इट हैज लर्न टू मच. करेक्ट? सो overfitting model may produce good predictions for data points in the training, but performance on new sample will be very less. In overfitting, the machine is not well tuned to the training set. Machine का training ही properly नहीं हुआ है, तो testing दूर ही रहा. So resulting model not captures the relationship between the input and output. So the predictions will not be proper. It will give me poor prediction. So what can we do if my model is overfitting, if my model is underfitting? What can be done to reduce the model complexity? We will reduce the model complexity by reducing the number of input features. Just now I gave you example, जैसे हमें घर खरीदने जाना है तो I will tell the area, I will have to tell the neighborhood, I will have to tell the square feet, I will have to tell the number of bedrooms, number of balconies, and so on. So I will have to reduce the number of input features to reduce the complexity of the model if my model is overfitting, and I will have to apply some of the regularization technique to overcome the overfitting of the model. अब अगर मॉडल अंडरफिट है, so what we need to do? We need to increase. Now vice versa can be done. If it is underfitting, we need to provide proper training by giving more number of parameters, by doing more training, by increasing the number of epochs. कितने देर आपको कितने epochs के लिए ट्रेन करना है उसको, और ज्यादा से ज्यादा ट्रेनिंग देके हम हमारे अंडरफिटिंग को एलिमिनेट कर सकते हैं. So this is regarding the overfitting and underfitting issues. Now see, whatever we have discussed, this 4 circle will show you what I told you, bias and variance. Now reducing the error for overfitting and underfitting is reduce the bias variance trade-off. Another interview questions, the people ask what is bias and variance trade-off. So reducing the error, training and testing error and making a good model, that is the bias variance trade-off, which is aiming to find a good fit model in between. हाई बायस भी नहीं होना चाहिए, हाई वेरिएंस भी नहीं होना चाहिए, इसका प्रॉपर बैलेंस होना चाहिए, दैट इज कॉल्ड एज द ट्रेड ऑफ. सो दीज आर द 4 circles or the 4 images which you can see. The first image is showing you a good model which is having low bias and low variance. आप देख सकते हैं ब्लू और रेड डॉट्स जो है एक साथ सेंटर में दिख रहे हैं. ट्रेनिंग और टेस्टिंग एरर आपको यहाँ पे कम दिख रहा है. सेकेंड फिगर इज शोइंग यू लो बायस. Low bias means what? The training error is given low, and high variance is showing you what? The blue color dots are spreaded. There is a spread in the data जो नहीं होना चाहिए, क्योंकि अगर ज्यादा spreaded data रहेगा तो वो error हमें ज्यादा देगा. तो we don't need high variance. Again, the third figure shows you high bias and low variance. High bias means what? Again, the training error is too much. But variance is why low? Because all the blue dots are at one place. They are not scattered. Therefore, it is given low variance. Variance में हमारा जो डेटा रहता है वो scattered होता है. हमें high variance नहीं चाहिए. We need low variance. And fourth figure is showing you कि जो training data है, training error भी आपका high है, क्योंकि dots देखिए कितने दूर दूर है, blue and red again circle. And the data is also spreaded. So high bias, high variance model is not needed. So we need to go with low bias and low variance. So this is the bias and variance trade-off. So these are the regularization technique to prevent the overfitting and underfitting. Overfitting and underfitting prevent करने के लिए काफी सारी टेक्निक्स होती है. रेगुलराइजेशन टेक्निक उसमें से एक है. क्रॉस वैलिडेशन भी एक टेक्निक होती है जो हम ओवरफिटिंग को रिड्यूस करने के लिए यूज करते हैं. सो इन रेगुलराइजेशन व्हाट डू वी यूज अ पेनाल्टी टर्म. अब हम मॉडल को क्या बोलेंगे कि भैया अगर आप ओवरफिट हो रहे हो, अगर आप अंडरफिट हो रहे हो, इफ यू आर नॉट गिविंग मी प्रॉपर रिजल्ट, आई विल पेनलाइज यू, आई विल एड अ पेनाल्टी टर्म. और जितनी ज्यादा पेनाल्टी रहेगी उतना मॉडल हमारा खराब होगा. करेक्ट? कोई भी बोलता ना हम पे पेनाल्टी नहीं बैठनी चाहिए. सो लाइकवाइज we do here. So lasso regularization, also known as L1. See, 2 types of regularization techniques are there, L1 and L2. L1 is called as lasso regularization and L2 is called as ridge regularization. So यहाँ हम क्या करते हैं आप देखिए, y minus y hat square, ये तो हमने error निकाला है, actual और predicted का क्या error होता है. And here we try to add a penalty term where it is alpha mod of m. तो हम क्या करेंगे, sum of absolute value of coefficient to the loss function we are adding, और हम उसको जीरो करने की कोशिश करेंगे. So see, lasso encourages sparsity by bringing some coefficient to exactly zero, removing their impact on prediction. तो ऐसे फीचर्स जो मेरे प्रेडिक्शन में इम्पैक्ट नहीं कर रहे हैं, वैसे फीचर्स को हम जीरो करने की कोशिश करेंगे. It also performs feature selection, effectively selecting the most important features and disregarding irrelevant one. So whenever we have high dimensional data set wherever we have n numbers of features, so this is very important to see the impact of the features and thereby reducing the irrelevant features. Second is ridge regularization, which is a L2 regularization. What it is doing, it is adding the square of that coefficients to the loss or penalty function. पहले में हमने mod लिया है, सेकंड में हमने उसका स्क्वायर लिया है पेनल्टी टर्म का. So ridge is useful when the data has multi-collinearity, जहां पे आपके प्रेडिक्टर वेरिएबल, जहां पे आपके इंडिपेंडेंट वेरिएबल्स हाईली कोरिलेटेड रहता है, वहां पे हम ridge regularization टेक्निक यूज करते हैं. और थर्ड रेगुलराइजेशन टेक्निक यहाँ पे आती है, विच इज कॉल्ड एज इलास्टिक नेट रिग्रेशन, विच इज अ कॉम्बिनेशन ऑफ L2 and L1, where in L1 mod of the coefficient is taken, in M2 the square of the coefficient is taken, and according the feature selection is being done. So these are the 3 regularization techniques. Now the second type of supervised algorithm, we have done the regression, we have seen the simple linear regression, we have seen the multiple linear regression, we have seen what is the objective, what we have to do with the cost function, we have to minimize the cost function that we have seen. Again, after that, we have gone through what is overfitting, what is underfitting. अगर ओवरफिटिंग अंडरफिटिंग आता है तो हमें क्या यूज करना चाहिए, रेगुलराइजेशन यूज करना चाहिए. वी हैव सीन 3 types of regularization we have gone through: L1 regularization, L2 regularization, and elastic net regularization. After that, we are moving towards second type of machine learning algorithm, that is classification algorithm. Now regression was dealing with the numeric value, whereas classification will deal with sorting input data into predefined categories. Now you can see here, if a customer group is given to me, what I have to classify based on that. अगर कोई कंपनी है, सपोज इंश्योरेंस कंपनी का मुझे डेटा सेट दिया गया है, एंड इफ आई हैव बीन टोल्ड कि आप इसमें से कैटेगराइज करिए कि कितने कस्टमर रिटेन होंगे और कितने कस्टमर इंश्योरेंस कंपनी का ये क्लेम छोड़ देंगे. सो दैट इज द टाइप ऑफ वर्क वी हैव टू डू इन द classification. Given a number of customer, we need to classify likely to stay and likely to leave type of customer. If a mail is given to us, we need to classify it into the spam or non-spam. If the image is given to me, I have to classify the image into some of the categories. So that is the task of classification. So one algorithm that we will go through for classification, जैसे हमने regression में हमने simple और multiple regression देखा, वैसे classification में we will go to SVM. So support vector machine is one of the widely used classification algorithm. Now, how the support vector machine is doing the classification? Like in simple linear regression, we find out the best fit line. Best fit line हमने find की थी y is equal to mx plus b. हमने best parameters find out किया था, cost function को reduce किया था और prediction किया था. तो SVM क्या use करता है? SVM use करता है marginal, the hyperplane. You can see in the image, the classification of SVM is done by the hyperplane. The best boundary, it is called as best boundary, जो क्या करता है, दो classes को separate करता है. It performs the classification based on this hyperplane. The larger the margin, the better will be the classification. So, what is the hyperplane? It is a decision boundary. कि एक data set आता है, तो hyperplane will classify whether it should belong to class A or class B. It can be used for binary classification also, or it can be used for multi-class classification also. जहां दो ही class होते हैं उसको binary class बोलते हैं, जहां दो से ज्यादा class वो होते हैं, we called it a multi-class classification problem. So what is the job of hyperplane? Classify the sample into the various classes. Now what are the support vectors? Now you can see ये hyperplane के आजू बाजू में आपको एक green color का and blue color का points नजर आ रहा है. So the closest data point which are there near the hyperplane, those closest data point are called as support vectors. Those are called as support vectors. The points which are closer to the hyperplane. And margin is what? You can see the margin, the dotted line. These are the margin. The distance between the hyperplane and the support vectors. These are called as margin. There are two types of margin. One is called as hard margin, one is called as soft margin. अब हार्ड मार्जिन यानी क्या होता है? The hard margin will not allow any misclassification. कभी कभी होता है ना, if a image of dog and cat is there, तो बच्चा कभी गलती से डॉग के इमेज को कैट बोल देता है एक आध बार कि this the images of cat. So that is not a hard margin. Hard margin क्या एक्सपेक्ट करेगा? अगर जिसका कैट का इमेज है तो आउटपुट भी प्रिडिक्टेड में कैट ही होना चाहिए. It will not allow any kind of misclassification of the data. Another type of margin is the soft margin, which can allow some kind of misclassification in the data. Now, there is another important concept in SVM which is called as kernel. So, what is the role of kernel? A function, kernel is nothing but a function which will map data to high dimensional space, enabling SVM to deal with non-linearity. Again, I told you that x and y अगर linearly variable है, एक दूसरे को लेके proportionally change होते हैं, so that is a linear data set. But if the data set is non-linear, like in second image you can see, then we have to find a new function which will help map this non-linearity. So kernel is that function which will deal with non-linear data. There are three types of kernel: linear kernel, polynomial kernel and radial basis kernel. अब आप पूछेंगे कि मैम वहां पे रेगुलराइजेशन यूज कर रहे थे ओवरफिटिंग अंडरफिटिंग के लिए, उसके बाद हमने पेनल्टी भी लगाई थी रेगुलराइजेशन में, तो क्लासिफिकेशन में नहीं होता है क्या ऐसा कुछ? तो क्लासिफिकेशन में भी रेगुलराइजेशन टर्म हम ऐड करते हैं, which is the C. It is a regularization term which is balancing margin maximization and misclassification penalty. यहाँ पे भी अगर misclassification होता है तो penalty add होती है in the form of C, और यहाँ पे वो loss count होता है in the form of hinge loss, जो penalize करता है अगर आपका मॉडल misclassification करता है. One more important thing I would like to add here that कई बार लोग पूछते हैं हाइपर पैरामीटर ट्यूनिंग, हाइपर पैरामीटर ट्यूनिंग. तो ये जो पैरामीटर्स आप पढ़ रहे हैं L1, L2, C, दिस इज अ पार्ट ऑफ हाइपर पैरामीटर ट्यूनिंग. ये पैरामीटर क्या होना चाहिए, ये हमें ऑप्टिमाइज करना होगा. सो अगेन दिस इज द ऑब्जेक्टिव फंक्शन, मैक्सिमाइज द मार्जिन एंड मिनिमाइज द पेनाल्टी. सो हिंज लॉस विल डू दैट. अगर डेटा पॉइंट करेक्टली क्लासिफाई है तो पेनल्टी 0 रहेगा हिंज लॉस. अगर वो इनकरेक्टली क्लासिफाई करता है तो hinge loss will go on increasing, जो हमें नहीं करना है. So that is the basic concept, and these are the various important concepts like hyperplane, support vectors, kernel function, hinge loss. These are the various important the parameters or the factors or the points that are to be taken care with the support vector machine model. Now these are the advantages of support vector machine: high dimensional performance, non-linear capability, kernel function यूज करके हम non-linear डेटा को भी मैप कर सकते हैं. सॉफ्ट मार्जिन की वजह से कुछ मिस क्लासिफिकेशन यहाँ पे अलाउ होता है, और ये सपोर्ट करता है बाइनरी क्लासिफिकेशन ऑल्सो एंड मल्टी क्लास क्लासिफिकेशन ऑल्सो. एंड व्हाट आर द डिसएडवांटेजेस ऑफ एसवीएम नाउ? the model becomes too bulky, so it is slow for large data set. Again I told you that hyperparameter tuning और parameter tuning जो हम बोलते हैं, जहां हम राइट कर्नल को सिलेक्ट करना, सी को एडजस्ट करना, ये सारा टास्क एक डिफिकल्ट हो जाता है. तो हाइपर पैरामीटर ट्यूनिंग बिकम्स अ क्वाइट डिफिकल्ट टास्क इन एसवीएम. इट इज सेंसिटिव टू नॉइज, मतलब ओवरलैपिंग क्लासेस, नॉइजी डेटा सेट में ओवरलैपिंग क्लासेस अगर मल्टी क्लास क्लासिफिकेशन रहा तो डिफिकल्ट हो जाता है. एंड देन स्केलिंग सेंसिटिविटी, फीचर स्केलिंग इज इसेंशियल, अदरवाइज एसवीएम मॉडल में परफॉर्म पुअरली. So this is regarding the advantages and disadvantages of SVM. Now we switch to another type of category which is called as unsupervised machine learning. हमने अभी तक unsupervised पढ़ा, हमने अभी तक supervised पढ़ा, जिसमें हमने regression देखा, जिसमें हमने classification देखा. Now we switch to second type of machine learning technique which is called as unsupervised learning. So in unsupervised learning, we have three categories. One is called as clustering, one is called as association rule mining, and third is called as dimensionality reduction. So clustering में what we do, as the name indicate, हम groups form करते हैं based on some similarities, correct? Again, that similarities we use some distance formula like I told, Euclidean, Manhattan, and so on. In association rule mining, we find the relationship like a priori algorithm हम use करते हैं. Dimensional reduction, we simplify the data set by reducing the number of features while retaining the important features. So here various type of clustering algorithms, I will name some. Centroid based method is used, distribution based method is used, connectivity based method is used, density based clustering method is used. So there are n number of clustering methods. Association rule, as I told you, find patterns between items in large data set. Dimensionality, reducing the number of features. That is principal component analysis is widely used for dimensional reduction nowadays, and it gives good result also. So these are various types of clustering. K means hierarchical, DB scan, mean shift, spectral clustering. So we'll see one type of clustering algorithm. K means clustering. This example and this execution of some of the algorithms will be taken in the subsequent sessions also. Hands-on sessions will be provided. Now in brief we will see how this algorithm work. We begin by randomly selecting K clusters. Clustering algorithm नाम है हमारा इसका. तो हम randomly क्या करते हैं, we choose the K clusters. जैसे हमने यहाँ पे 2 clusters बनाए हैं पहले. Each data point is assigned to the nearest centroid forming clusters. उसका nearest clusters को वो data point assign होंगे. Again we will do the recalculation of the centroid of each clusters and by averaging the points within it. सबके points के average निकाल के फिर से clusters को हम change करेंगे and accordingly the nearest point group होते जाएंगे and the process repeats until the centroids no longer change और द मैक्सिमम नंबर ऑफ इटरेशंस इज रीच. अगर आप 10 इटरेशंस के लिए रन करते हो एल्गोरिथम को तो आप तब स्टॉप कर सकते हैं और अदरवाइज इफ देयर इज नो चेंज, कभी कभी सेंटर्स के जो पॉइंट आते हैं C1 C2 वो चेंज नहीं होते. सो नाउ एट दैट इज द पॉइंट वेयर वी नीड टू स्टॉप एंड द क्लस्टर्स आर फॉर्म. सो K मींस क्लस्टरिंग. Now you will see how we will select the value of the K, how we will come to know how many clusters has to be formed in K mean clustering. So selecting the right number of clusters is important to do and what we use elbow method for optimal value of K in K means. So हम बोलते हैं कि K हम कैसे find करेंगे, कैसे choose करेंगे, कितने clusters चाहिए by elbow method. So in elbow method what do we do? There are suppose 10 clusters you can see in the image, correct? And we compute the सम ऑफ स्क्वायर्स. अभी हमने काफी जगह सम ऑफ स्क्वायर्स का ये देखा कैसे हमने एरर निकाले थे. यहाँ पे भी हम विद इन क्लस्टर्स वो पर्टिकुलर क्लस्टर्स के लिए विद इन क्लस्टर सम ऑफ स्क्वायर एरर निकालेंगे और हर क्लस्टर के लिए उसकी वैल्यू प्लॉट करेंगे. तो आप जब देख रहे हैं K की वैल्यू 1 है तो एरर हाईएस्ट है, K की वैल्यू 2 है, क्लस्टर्स 2 बन गए, एरर की वैल्यू थोड़ी कम हुई, क्लस्टर्स 3 बने. अगर आपने 3 क्लस्टर लिया है तो वैल्यू इज गोइंग ऑन डिक्रीजिंग. द सम ऑफ स्क्वायर एरर इज गोइंग ऑन डिक्रीजिंग एज यू इंक्रीज द नंबर ऑफ क्लस्टर्स. सो सी द फोर्थ पॉइंट, it is like the 4th and 5 means 4 and 5 are the clusters which represents the elbow like shape. तो ये exact point होता है जहां हमें K की वैल्यू फिक्स करनी होती है. So this is one of the method for selection of number of clusters in clustering algorithm. And then we switch to the third type of machine learning which is called as reinforcement learning. Now reinforcement learning के काफी सारे applications, as I told you earlier also, कि it interacts with the environment, take the action, interact with the environment, and based on the feedback it will improve itself कि आगे ये move लेना है या नहीं लेना है based on the reward and penalty. So some of the applications of reinforcement learning are in robotics, where it allows machine to learn complex tasks like grasping objects, walking, flying drone autonomously. So these are the various areas where reinforcement learning is playing a big role. Then autonomous vehicle we are seeing nowadays, where reinforcement learning has optimized driving decisions such as acceleration, braking, lane changing. And then in gaming also it is playing very important part. For example, AlphaGo defeating world champion in the game of Go. This was the news a days back. It is also used in finance for dynamic portfolio management. वो देखेगा कि कहाँ रिवॉर्ड ज्यादा मिल रहा है, कहाँ हमें लॉस हो रहा है, इस हिसाब से वो पोर्टफोलियो हमारा फाइनेंस में मैनेज करेगा. एंड इन हेल्थ केयर ऑल्सो nowadays reinforcement learning is used, and for energy systems for optimizing power consumption. And so this is regarding the types of supervised learning, regression, classification, unsupervised clustering, and then reinforcement. So this is just a gist which I have given. So now as we conclude, it's important to look ahead at how AI continues to evolve. Generative AI has opened entirely new dimensions by enabling creativity, design, and automation at human-like levels. In the near future, we can expect AI to become more content-aware, emotionally intelligent, and ethically responsible. Research is moving towards explainable AI, trustworthy AI, and sustainable AI. We should try to develop an applications which are sustainable nowadays. The 7 sustainable goals are given to it, and we should now map our projects, map our research to attain the sustainable goal and attach to the national mission also. And it should build a system to ensure that they are transparent, fair, and energy efficient. So the integration of AI with IoT, edge computing, blockchain, and quantum computing is also shaping the next industrial transformation, often called Industry 5.0, where human and intelligent machine collaborate seamlessly. So we should now focus on the subjects which we have mentioned here: try to make our research, try to embed our student in such kind of research, and should contribute in forming the aims of Industry 5.0. So this was all from my side to the basics of introduction to AI and ML. Vinod sir, Vinod sir, am I audible? Vinod sir?
तुम्हाला आवाज येत आहे प्लीज.
Ah, madam.
Yes, sir. I have done with my presentation.
Yes, your presentation is very nice, ma'am.
Yeah.
Because already the uh, faculty members are given the feedback for us.
Okay. Thank you,
And,
ji.
ah, okay, the vote of thanks given by the Kumar Lokhande madam now.
Good afternoon to all. On behalf of RIT College, I sincerely thanks our Rajna ma'am for sharing such valuable insights during today's FDP session. My heartfelt thanks to our principal sir for their constant support and all participants for your active engagement and time. Thank you everyone for making this online session a great success. So I conclude that session is over.
Thank you all. Thank you all.
Next session will be continued as per the schedule.
All the participant, the feedback link will be shared to your WhatsApp group. Please fill that feedback form so that your attendance and all these things are recorded. Okay. Okay.